Hey guys, how's it going? This is Austin Dennis back with another TryHackMe walkthrough. Today we're going to be looking at the OSI model, or the OSI model for short, and this is very important for foundational knowledge to understanding how a network works, how it's laid out and everything. So we will be going through this. So for task number 1, what is the OSI model? The OSI model, or Open Systems Interconnection Model, is an absolute fundamental model used in networking. This critical model provides a framework dictating how all network devices will send, receive, and interpret data. One of the main benefits of the OSI model is that devices can have different functions and designs on a network while communicating with other devices. Data sent across a network that follows the uniformity of the OSI model can be understood by other devices. The OSI model consists of 7 layers, which are illustrated in the diagram below. Each layer has a different set of responsibilities and is arranged from layer 7 to layer 1. At every individual layer that data travels through, specific processes take place and pieces of information are added to this data, which is what we'll come to discuss in the upcoming tasks in this room. However, for now, we only need to understand that this process is called encapsulation and what the OSI model looks like in the diagram below. So this is a basic, pretty much as basic as you can get when it comes to the OSI model, all the way from application, presentation, session, transport, network, data link, and physical. So for the questions below, it says, what does OSI and OSI model stand for? We got that answer right up at the top here, which is Open Systems Interconnection. And you can just copy that, paste it down below, and we've got it right. How many layers and digits does the OSI model have? And we saw that here. It is a 7-layer room. The answer to that question is 7. And what is the key term for when pieces of information get added to data? Now, that term is called encapsulation. That was the thing that it wanted you to remember before you moved on to the next room. So just understand there's 7 layers. These are what those 7 layers are. And the term for how data gets transported and the way that it gets transformed is basically called encapsulation. So the application layer, number 7. The application layer of the OSI model is the layer that you will be the most familiar with. This familiarity is because the application layer is the layer in which protocols and rules are in place to determine how the user should interact with data sent or received. Everyday applications such as email clients, browsers, or file server browsing software such as FileZilla provide a friendly graphical user interface, or GUI, for users to interact with data sent and received. Other protocols include DNS, domain name system, which is how website addresses are translated into IP addresses. So the name of this layer is application. And the technical term that is given to the name of the software that users interact with is graphical user interface. So graphical user interface is literally basically what you're looking at right now. You're looking at a screen capture of me using Google Chrome. I'm connected to TryHackMe using port 443, and I'm able to interact with this web server through the internet and everything else. So you'll learn a lot more about that, but there's a ton of things that happen behind the scenes that if you're not technologically savvy with, you're not really going to understand. And this is all simplified by using a GUI, or graphical user interface. Some things, you don't have the option of using the GUI with, but that's what all these operating systems do in applications. And basically this model that we're learning about is it takes everything all the way from the zeros and the ones at the very bottom and gets it translated all the way up to an actual user interface. And number 7, the application layer, is where you're dealing with the user interface. Layer 6, the presentation layer. Layer 6 of the OSI model is the layer in which standardization starts to take place. Because software developers can develop any software, such as an email client, differently, the data still needs to be handled in the same way no matter how the software works. This layer acts as a translator for data to and from the application layer. The receiving computer will also understand data sent to a computer in one format, destined for another format. For example, when you send an email, the other user may have another client email to you, but the contents of the email will still need to display the same. Security features such as data encryption, like HTTPS when visiting a secure site, occur at this layer. So the name of layer 6 is the presentation layer. Oh, if I can spell it right. presentation. What is the main purpose that this layer acts as? It says right here in the second paragraph, this layer acts as a translator for data to the application layer. So the thing that it's looking for there is that it is a translator. You don't have to add the slash in. That was just me accidentally bumping that as I hit my enter key. Layer 5, session. So once data has been correctly translated or formatted from the presentation layer, layer 6, the session layer, layer 5, will begin to create a connection to the other computer that the data is destined for. When a connection is established, a session is created. Whilst this connection is active, so is the session. The session layer, layer 5, synchronizes the two computers to ensure that they are on the same page before data is sent and received. Once these checks are in place, the session layer will begin to divide up the data sent into smaller chunks of data and begin to send these chunks packets at one at a time. This dividing up is beneficial because if a connection is lost, only the chunks that weren't yet sent will have to be sent again, not the entire piece of the data. Think of it as loading a save file in a video game. What is worthy of noting is that sessions are unique, meaning that data cannot travel over different sessions, but in fact only across each session instead. So for the first question, what is the name of this layer? Session. What is the technical term for when a connection is successfully established? And the same thing as answer number 1. A session is created, hence the name session layer. And the technical term for small chunks of data is packet. Packets. So we're not dealing with just one thing, we're dealing with multiple packets, and when we get down further on, we will see single packets. So layer number 4, transport. It says layer 4 of the OSI model plays a vital part in transmitting data across the network and can be a little bit difficult to grasp. When data is sent between devices, it follows one of two different protocols that are decided based upon several factors. So you have TCP and UDP. So let's begin with TCP, the Transmission Control Protocol, potentially hinted by the name. This protocol is designed with reliability and guarantee in mind. This protocol reserves a constant connection between the two devices for the amount of time it takes for the data to be sent and received. Not only this, but TCP incorporates error checking into its design. Error checking has TCP can guarantee that data sent from the small chunks in the session layer has been received and reassembled in the same order. So let's summarize the advantages and disadvantages in the TCP table below. So advantages: guarantees the accuracy of the data. It's capable of synchronizing two devices to prevent each other from being flooded with data. Performs a lot more processes for reliability. The disadvantages of it: it requires a reliable connection between the two devices. If one small chunk of data is not received, the entire chunk of data cannot be used. A slow connection can bottleneck another device, as the connection will be reserved on the receiving computer the whole time. And TCP is significantly slower than UDP because more work has to be done by the devices using this protocol. So TCP is used for situations such as file sharing, internet browsing, or sending an email. This usage is because these services require the data to be accurate and complete, no good having half a file. In the diagram below, we can see a picture of a dog is broken down into smaller pieces of data known as packets from the web server, where the computer reconstructs the picture of the dog into the correct order. Now let's move on to the User Datagram Protocol, or UDP for short. This protocol is not nearly as advanced as its brother, the TCP protocol. It doesn't boast the many features offered by TCP, such as error checking and reliability. In fact, any data that gets sent via UDP is sent to the computer whether it gets there or not. There is no synchronization between the two devices or guarantee, just hope for the best and fingers crossed. While this sounds disadvantageous, it does have its merits, which we'll lay out in the table below. So for example, UDP is much faster than TCP. UDP leaves the application layer, user software, to decide if there is any control over how quickly packets are sent. UDP does not reserve a continuous connection on a device as TCP does. UDP doesn't care if the data is received. It is quite flexible to software developers in this sense. This means that unstable connections could result in terrible experience for the user. So, using the same example as before, we can now see that only packets 1 and 3 have been received by the computer, meaning that half of the image is missing. So the whole entire picture is a weird picture of a dog that doesn't have eyes and its eyebrows are down by its face. So it's important to understand what you're using. And these protocols are all decided based on which is going to be the most effective. So the thing is, when you're reading through this, you might be looking at it and think, well, what would ever be a purpose that you'd use UDP for if you can't guarantee the delivery of the data? Well, think about a phone call. When you're talking to somebody on a phone call, every once in a while you'll have things slowly drop out. But imagine if basically every second of sound had to go through a longer, strenuous process, and then everything's just all broken up and not together. When you're talking on the phone with somebody, speed is the bigger priority. But when you're transferring files to somebody, accuracy is the bigger priority. So when you think about TCP, so UDP is basically, if I'm wanting to talk to you, I just immediately say something to you, and basically I don't care whether you're listening to me or not. I say it to you, and then I just assume that you got that information. I'm not going to check with you. I'm not going to verify that you heard it. I'm just going to assume that you heard it and move on and do whatever else I was doing. TCP, before I would even send that information to you, I would basically come up to you, I would tap on your shoulder, I would say, hello, I have information for you to send. You would then say back to me that, hello, I hear you. I acknowledge that you have information that you want to send to me, and then I would acknowledge back to you that you're going to receive the information that I'm going to send you, and then I would send the information to you. So that's how the reliability gets ready. If you're thinking about a UDP, it's basically if you're just walking up to somebody, you're telling them information, and you just assume in your head whether they say anything back to you or not, it doesn't matter. The fact that you said it is that they heard it. But TCP is basically 100% ensuring that the person that you're saying something to gets it. So the name of this layer is the transport layer. And TCP stands for, I'll just copy it because it's a little bit longer, it's the Transmission Control Protocol. So that is basically something, and oftentimes you'll hear about a TCP handshake. So when I talked about you talking to somebody and acknowledging them, then that's what it's referring to. So for the fourth question, what does UDP stand for? You can go ahead and copy user datagram protocol and post that down. And then here, it's got just a couple questions for you to answer and ensure that you understand what these are doing. And don't try to understand all the deep-rooted, all the way down to the skeleton, the way these things are working. Just think about the questions that it's asking. Make sure that you just understand basically what the question's asking so that you can differentiate between the TCP protocols and the UDP protocol. So, what protocol guarantees the accuracy of the data? That would be the TCP protocol. What protocol doesn't care if data is received or not by the other device? That would be UDP. You're not checking. What protocol would an application such as an email client use? That would be TCP. What protocol would an application that downloads files use? That'd also be TCP. You don't want to download files and get things in different parts and not all at once and come up with a really weird corrupted file at the end of it. What protocol would an application that streams video use? That would be UDP, and we have completed that task. So layer number 3, which is the network layer. It says the third layer of the OSI model, network layer, is where the magic of routing and reassembly of data takes place, from these small chunks to the larger chunk. Firstly, routing simply determines the most optimal path in which these chunks of data should be sent. While some protocols at this layer determine exactly what the original or the optimal path that data should take to reach another device, we should know about their existence at this stage of the networking module. Briefly, these protocols include OSPF, Open Shortest Path First, and RIP, Routing Information Protocol, the factors that decide what route is taken by the following. So sometimes it'll ask itself, what path is the shortest, or which has the least amount of devices that the packet needs to travel across. What path is the most reliable? Have packets been lost on a path before? Which path has the faster physical connection? For example, one is a copper connection or one is a fiber, which is considerably faster. At this layer, everything is dealt with via IP addresses such as 192.168.100. Devices such as routers capable of delivering packets using IP addresses are known as layer 3 devices because they are capable of working at the third layer of the OSI model. So the name of this layer is the network layer. And will packets take the most optimal route across the network? The answer to that is yes. And the way that it figures out the most optimal path is basically whatever it's looking for. So for example, pretend that this router doesn't exist and that there's just a line that goes straight across this one. So let's say that this line that would go from computer A to computer B right between these two routers would transfer the data at 100 megabits a second. But then these two would transfer it at a gigabit a second. So significantly faster, but it only has to go across one hop. This is what it's talking about. So basically, if you're using a protocol that's going to check for, it's a distance vector protocol. So basically, it's just trying to find out what's the shortest path in terms of number of devices that we would need to connect. So if computer A is trying to reach computer B, there's a line going from here. This would be 1, 2, 3 hops that you would have to take in order to get to those, even though it would actually be slower than just taking an extra hop. But that's not what that protocol is looking for. So if you've got a protocol that is looking for the fastest speed, which there are plenty of those out there, and usually they're more optimal, you would actually take a second hop. You wouldn't just try to go straight from there to there, because it would be considerably faster to use the gigabit speed to make it to computer B. So that's kind of something that's happening at the network layer, and that's what you're dealing with the routing protocols that are down there. So what does the acronym OSPF stand for? That is Open Shortest Path First. I can spell that right. Open Shortest Path First. And the acronym RIP stands for Routing Information Protocol. And what type of addresses are dealt with at this layer? This is IP addresses where they are dealt with. Now, layer number 2, the data link layer. The data link layer focuses on the physical addressing of the transmission. It receives a packet from the network layer, including the IP address for the remote computer, and adds in the physical MAC address, media access control address of the receiving endpoint. Inside every network-enabled computer is a network interface card, which comes with a unique MAC address to identify it. MAC addresses are set by the manufacturer and literally burnt into the card. They can't be changed, although they can be spoofed. When information is sent across a network, it is actually the physical address that is used to identify where to send the information exactly. Additionally, it is also the job of the data link layer to present the data in a formidable solution for transmission. So the name of this layer is data link. And the name of the piece of hardware that all network devices come with is a network interface card. The first layer, the physical layer. So this layer is one of the easiest layers to grasp. Put simply, this layer references the physical components of the hardware used in networking, and its lowest layer that you will find. Devices use electrical signals to transmit data between each other in binary numbering systems. This is where you get down to the ones and to the zeros. For example, Ethernet cables connecting devices such as the diagram below. So the name of this layer is the physical. And the name of the numbering system that is both zeros and ones is the binary system. And the name of cables that are used to connect devices would be Ethernet cables. If you're watching this on a computer, you might actually have an Ethernet cable connected to you now. I don't know if you can see it in the background, but I do have or you should definitely be able to see this. This is an Ethernet cable running from my ceiling into my basement that connects my computer, so I don't have to deal with the Wi-Fi. Ethernet's usually significantly faster if you can use an actual wired connection into your computer. But like I mentioned earlier, this is what the whole entire purpose of the OSI model is. You know, you're not just learning about random networking devices for nothing. You're learning about the foundation of the way that data transforms from all the way to your Ethernet cable all the way to the computer screen. So basically, layer 1 is easy to grasp because you can physically look at the device that you're working on, especially if you're on a desktop computer or you're using a laptop connected to Ethernet. You can physically see the computer that you're using, the Ethernet cable that you have, And then everything in between that, layer 2, layer 3, layer 4, layer 5, layer 6, and layer 7, is how you get everything that's coming through the cable to the screen that you can actually physically see, the graphical user interface. And this is the thing that we're trying to do. The reason this is all important to know and understand for cybersecurity is that the thing that we're securing is data. Everything is data. So that we're trying to protect data, we need to understand it. So it's important to understand what's going on at the data link layer, the network layer, the transport layer, session, presentation, and application, and the physical. If we understand all these things, it's really good to use this for troubleshooting and things like that, to where you can figure out what is happening, where it's happening, and you might be able to find somebody on your network by going through this layer if you're troubleshooting and find something like that. So now we've got a dungeon to escape. So if you climb the levels in the correct order to escape the dungeon and reveal the flag, can you beat our staff high score of 19 seconds? Since this is a walkthrough and I'm talking through it, I doubt that we'll be able to do that. So here is the OSI dungeon. We've got to insert a coin, which is going to happen by just clicking play. It says a hacker has been locked in the dungeon. Their only chance of freedom is by choosing the correct path based on the OSI model. Use your cursor keys to move left and right in the space bar to enter doors. So when I click play, we're going to be able to move around here. So we're at the very bottom. We need to go to the physical layer. We made it. Now the next layer would be the data link layer. Now we've got the network layer and transport layer and the session layer, presentation layer, and then finally the application layer. So we have made it. Only did it in 26.55 seconds, but we're not going for time. We're just doing it to understand what's going on and understanding what the order of it is. So one thing that you can try to use to basically remember this is there's a little acronym, because it's good to have this memorized, understand what all of these are. A good acronym that you could try to remember this would be all people seem to need data processing. So remember that, APSTNDP. All people seem to need data processing. That'll help you remember that. And this very bottom one is just telling you to join the next room and complete it, but we have completed another room. So this was the OSI model. This is a really important one. Don't just try to think through the answers and just complete this room and just blow by it. It's an easy thing to do. All of the answers are basically given to you in the text of the thing, but try to really understand this, internalize it, especially that layer 4, the transport one, where it's talking about the TCP and the UDP protocols. Really try to internalize that, see what it's talking about, see what it's asking you, and really just try to get this. This walkthrough that I'm doing, going through the pre-security learning path, is very important just for building foundational knowledge into your head for all of this stuff. It's very important to learn. It's very helpful to learn, and I hope that you'll stick with me as we keep on going through this learning path. Try to jot these things down. Try to make note of them, make memory of it. And I think that you'll really find it helpful as time goes on. So again, thank you so much for watching this video. We'll try to upload on Mondays, Wednesdays, Fridays, and then capture the flag challenges on Saturdays. I hope that you will stick around and subscribe to the channel if you're not already subscribed. Like the video, share it with your friends if it's helpful to you, and leave a comment down below about something that you learned if you learned something new in this video. So thank you guys so much for watching. Hope to see you guys next time.